I'm going to show you how to do a reflection. Actually, the points are very few and very simple. I'm going to demonstrate them using these drawings. They're written here for your reference as well. Now, normally, a mirror line will either be vertical, horizontal, or exactly halfway, meaning at 45 degrees either this way or that way. Now, I have deliberately taken a mirror line which is at none of those. This orange dashed line is my mirror line, or line of symmetry, or line of reflection. I'm going to call it a mirror line. The reason I've done it at some other slope is to demonstrate that the rules are the same no matter what the slope of the mirror line. And I'm going to start with the simplest line, which is a straight line, and work my way to a curved shape. With any point, the reflection is on the opposite side of the mirror. That's the number one thing, that the reflection of any point will be on the opposite side of the mirror. And the other thing is that the reflection of the point will be exactly the same distance as the original point. But of course, the reflection is on the opposite side of the mirror. Now, with any straight line, the simplest way to reflect it is to reflect the two ends of the line. So let's take this line. This is one end. I'm going to mark a little cross just to make it clear what point I'm talking about. Now, that point, I can get the reflection of it on the opposite side of the mirror. So obviously the reflection is going to be on this side of the mirror. So if you say this is to the left, then the reflection will be to the right of the mirror. However, the reflection will be the same distance on the opposite side of the mirror. Now, distance is always going to be the shortest distance. So it's no good taking the horizontal distance in this case because it's not the shortest, nor a vertical distance because that's a long way to the mirror. You must always take the shortest distance to the mirror, which I'll indicate like this. So the shortest distance would always be the perpendicular distance, or distance measured at right angles to the mirror, like that. And if you imagine that that's about 3 centimeters, then you carry on to the opposite side of the mirror, again at right angles, and mark the position of the reflection of that little red cross. So the reflection would be about there. So obviously I'm doing it freehand and I'm estimating, but you can use a ruler if you want. You can use a set square just to learn the process. Now, the other end of the line, which I'll mark with a cross like this, you reflect in exactly the same way. So what you do is you measure the shortest distance from that point to the mirror, which again I'll estimate like this. And it has to be the shortest distance, so the perpendicular distance. And you measure the same distance but on the opposite side of the mirror. So again, I'm estimating it to be there, but you can measure it. And that would be the reflection of that far end of the line. And because it is a straight line, if I have plotted the two ends of the line correctly, I only need to join them up with a straight line to get the reflection. So that yellow line, that yellow solid line, represents the reflection of this white horizontal line in this mirror line. Now I'm going to repeat exactly the same method with this line. It's more complicated only because it is actually made up of 4 separate lines, but the principles are the same. Again, the points that I'm going to take, I'll mark them each with a cross. So that's one end here where there's a vertex, a bend, an angle if you like, and another vertex, and then this end. Now I'll label them 1, 2, 3, 4, 5. So that when we reflect, we know where the reflection of each point is. I'll just do them in order. Well, let's take 1. All I do is measure the shortest distance to the mirror, which is that, which remember is always the perpendicular distance, and then measure the same distance but on the opposite side of the mirror. and I estimate that to be there. Now that is the reflection of 1, so I'll label that one also as 1, but of course I'm doing all the reflections in yellow so you can tell them apart from the originals, which are in white. So there's the reflection of point 1. Now let's get the reflection of point 2. Exactly the same thing, the shortest distance to the mirror, the perpendicular distance to the mirror, and then measure exactly the same distance on the opposite side of the mirror, which I'm estimating to be there. That's the reflection of point 2. Same again with point 3. Same distance on the opposite side of the mirror. Okay, so I'm emphasizing to you that the reflection of any point is always on the opposite side of the mirror and exactly the same distance from the mirror, and the distance is always the shortest distance to the mirror, which means the perpendicular distance. So 4 is to the right of the mirror, so its reflection will be on the left side of the mirror. So I'm estimating it's going to be there, the reflection of point 4. And point 5 is also to the right of the mirror, so its reflection also will be to the left of the mirror. So the reflection must always be on the opposite side of the mirror. That, if you like, is the first rule of reflection. And I'm estimating it to be there. Now it doesn't look like much at the moment. However, if I now join those points up in order, then I should get the reflection of this zigzag line. Starting with 1 to 2, so that's my first piece, and then 2 to 3, then 3 to 4, and 4 to 5. So I'll make that a little thicker to make it clearer. And I've done it freehand, so it's not going to be a perfect reflection, but I've really just demonstrated how to do it. Now, there is the zigzag, and there is its reflection. I've done exactly the same thing here that I did here. It's only that instead of having only 2 points, I had 5 points here. And you can use that principle to reflect any straight line or any series of straight lines, or even a polygon in any mirror, meaning whichever way the mirror line slopes. Now, let's reflect this triangle. A triangle is easy because it has only 3 vertices. So we only need to reflect 3 points. So it's actually simpler than that zigzag shape. So if we label them 1, 2, 3, and repeat what I did before, which is to reflect each point. So the reflection of point 1 will be on the opposite side of the mirror, so it will be, the 1 is on the left of the mirror, so its reflection will be on the right of the mirror, exactly the same distance measured perpendicularly. So there is the reflection of point 1 of the triangle. Here is point 2, it's to the right of the mirror, so its reflection will be on the left side of the mirror. I measure the shortest distance to the mirror, which is roughly that, and measure the same distance on the opposite side, which is roughly there. And the same again with point 3, shortest distance to the mirror, and repeat it on the opposite side, which is about there. And there is a reflection of point 3. All that remains is for me to join up points 1, 2, and 3, or rather the reflections of points 1, 2, and 3. And there we have the reflection of the triangle. So it is a matter of focusing on individual points and reflecting into individual points and then joining them up in the right way. So what I've shown here with this triangle is that the reflection of any shape is the same size as the original and has the same angles. So obviously the angles are not in the same places because they'll be on the opposite side of the mirror. However, they are the same angles. So this very acute angle will be the same as this. This, which is an obtuse angle, will be the same as this. And this acute angle will be the same as this. Now what about curves? Curves can be trickier, but the principles are the same. All it requires is to take a few more points, if necessary, in order to get the right curvature. You obviously take the ends of the curve, but that's not enough, because you need to know where the curve bends and how much it bends. So it's a good idea with a curve to, if you like, take the extremes of the bends, the bulges. So I'll take a point here and a point here, 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 and obviously where it crosses the mirror line, the reflection will cross in the same place. Now I've taken quite a few points along the curve, and that will give me a good chance of getting a reasonably accurate reflection. I'll now label those points in order, so that when I join them up, I also join them up in the correct order. Okay, so in total I've taken 10. Now it's not necessary to take that many, but I'm just doing this to show you. Now, if you take one and reflect it, it'll be about there. I'll do it reasonably quickly because there are so many points to take. So there is my reflection of point 1. 2 is along the same line, but a shorter distance to the mirror. 3, a bit lower down, and slightly closer to the mirror again. I'd say about there. 4 is about there. 5, slightly closer to the mirror. It's about there. 6, closer again to the mirror, about there. It is important to keep track of which point is the reflection of which point, especially when you have quite a few. 7, its reflection is about there. 8 is actually on the mirror line, so its reflection will also be on the mirror line in exactly the same place. So 8 is on the mirror line. 9 is to the right of the mirror line, so its reflection will be to the left of the mirror line, about there. And 10, again, it's to the right of the mirror line, its reflection will be to the left of the mirror line, about there. So there I have 10 points of my reflection. Now, it's tricky to join up and get the exact curve, so mine will be approximate. But if you were doing this with pencil on paper, you can easily erase it and just make it a little more accurate. So the best thing is to do it faintly first, and then once you've got the curve right, going through all the points, you can make the curve just a little darker. Now, I can't do that by the nature of the pens, but I'm just following my finger to see that I can see that it curves upwards a little from 1 to 2, and then curves down through 3, and then bulges out as far as 4, and then curves back in towards the mirror through 5 and 6, and then curves towards 7, and then again towards the mirror at 8, towards 9, and then ends at 10. So I have an idea about how the curve goes. It goes like that. And I'll draw it in. But I don't want it to bulge a lot out, because I can see that it bulges only ever so slightly, going from 1 to 2. And there we have it. So I have just done a reasonably representative reflection of this curve. Now that was particularly complicated, and you wouldn't get something quite that complicated. But the point is, I haven't used any different principle here to what I used here. It's the same rules, if you like. Let's take this curved shape now. The same principles will apply again. I'll take fewer points to make it a little quicker. I certainly want to take that vertex and that, and I'll take the top of the curve, the point where it bends, the other way too, where it bulges out to its furthest distance, nearest to the mirror, and where it becomes more or less a straight line. Okay, now those points will suffice. So if I just follow them around, 1, 2, 3, 4, 5, 6, 7, 8. Reflect each one in turn as I've done with all the other points I've taken. 1 will be about there. 2, the reflection will be about there. 3's reflection will be about there. 4's reflection there. 5 is easy because it's so close to the mirror. 6, if I just extend the mirror line a little, about there. 7, and last, it's almost level with 1, but a bit closer to the mirror, about there. Now I join the points up in order. Now it's a bit tricky to do without first doing an approximate sort of faint line, but I'll give it a go. And it curves upwards from 1 through to 3, and then it carries on curving the same way towards 4. And then at 4, it reverses the curve to towards the mirror. So let's try that part. So at 4, it's going to reverse the curve towards 5. And at 5, it comes to a point. Then it curves towards 6 through 7. And then at 8, it again turns around to curve the opposite way. But it goes down, if you like, as low as 6, and then it curves up towards 7. And that's not very accurate, but it's reasonably accurate, and you can see that that is the reflection of this S-type shape. Very important about curves is that when you're trying to reflect a curve, it is useful to take, if you like, the top of the curve, the bottom of the curve, the furthest bulge away from the mirror, the closest bulge towards the mirror. That helps you to reproduce the reflection reasonably accurately. But also notice that the parts of a curve that curve away in the reflection must also curve away from the mirror line. So it's all in relation to the mirror line. And the parts that curve towards the mirror must curve towards the mirror in the reflection. I've shown you from the simplest to quite complicated shapes how to reflect, and the rules are the same throughout.